this afternoon at Char's Bluff, Spring Lake Park, and we're going to determine how dense is the woods. That's a good question. What do you mean when you say the density of a forest? Well, we simply mean how many trees are there in a prescribed plot. So I've set up a simple prescribed plot right here. It's a square and it's 3 meters on a side. I simply put a piece of rebar at each corner, marked them, and then ran a piece of flagging around the perimeter so that you can really easily see the prescribed plot. So the question is, how dense are the trees in this plot? The question is a good one because what do you mean when you say dense? Suppose you're in a woods and somebody said, wow, this is a really dense woods. Well, how dense do you mean? Or what if somebody said the converse? What if somebody said, wow, there's this density of this woods is so Spartan? Well, what do you mean by Spartan? So today, we're going to figure out how do you actually determine tree density. It's very simple. I'll show you. It's repetitive, but it's simple. So the first job is to pick a random spot in your plot. How to do that? Well, establishing randomness is a tough business, but here's how I would do it. I would stand with my back to one side of the plot. I'd simply take a stick like this one, throw it over my back. It landed in the plot right there. And now I'm going to take some measurements from that spot. So I'm going to take this piece of carpeting and I put it over the top of it, over the top of my random spot. And you'll notice that it's divided into quadrants: northeast, southeast, southwest, northwest. And I put a little sun toward the east. Obviously that direction is north. Now how do we know that our carpeting placed over that random spot is oriented the correct direction? Well, you can just use a compass. So I've got a compass right here, and I'll just show you the very basics in order to orient the carpeting. What you want to do is take red Fred and put him in the shed. So you'll notice there are two markings right here, two white markings next door to north, and there's a red arrow right here. That's Fred. Fred is red. We want to orient this so that red Fred is in the shed. So I'm going to turn this until I actually get Fred in the shed. And now I've got it. So I need to change my carpeting just a little bit so that it's pointed more the way this compass is pointed, such that red Fred is in the shed. Now that's pretty good. Okay, so I've got it oriented well now so that north is indeed that way and the sun in the east is directly that way. Okay, now with that in mind, what do? Well, you'd have to imagine that your spot is oriented such that there are quadrants. So here is the northeast quadrant. Now what you'd simply do is stand in the center of this carpeting, look for the closest tree that's in this quadrant and measure to it. So I am going right this way, and right here, this is Riverbank Grape. I would measure the distance to it. Now I'd have to go to this quadrant and do the same, southeast quadrant. Now you might have to go outside the prescribed area to actually get to a tree, but you'd measure to the closest one. Same way for the southwest, same way for the northwest. Measure to the closest tree that's within that quadrant. Now that is 4 measurements at one random spot. Now you'd simply repeat this for a total of 20 random spots. So 20 random spots times 4 measurements to the closest tree, that's 80 measurements. Not hard, it just takes a little bit of time. Now you'd take those 80 measurements and substitute them into a formula, and the formula will help you determine the tree density. Much better than simply saying, it's a pretty dense woods, or it's not a very dense woods. You'd have an actual mathematical calculation as to how dense is that forest.